Hello everyone, welcome to John Mac Classroom. In this lesson, we are going to be learning about the classification of number, which include the natural numbers, whole numbers, integer, rational numbers, irrational numbers, and real numbers. The most basic type of classification of numbers are the natural numbers. N is the symbol that we use to represent them. Natural numbers include the numbers such as 1, 2, 3, 4, 5, and so on. They are often referred as counting numbers. Kindly take notes that natural numbers do not include 0 or any negative number as well as any decimal numbers. The easy way to think about it is like this. We are naturally counting. Normally, we start counting from 1, 2, 3, 4, 5, and so forth. But rarely we counting start from 0. Therefore, this is the innermost basic classification of the numbers. The next layers of numbers is the whole numbers. Whole numbers can be often denoting by using the capital W. The classification of the whole number is exactly like the natural numbers in that it includes all the natural numbers and it also includes the 0. So, instead of starting from 1, whole numbers start from 0. Another cool way of remembering the whole number is to think about it like this. The whole numbers are the same as natural numbers, except they start with the number 0, which looks like a whole. Therefore, whole numbers include natural numbers, and this means that any natural numbers is also considered as a whole numbers. But not necessarily the other way around, since 0 is not in the natural numbers. The next classification of numbers is something that you are like to have heard before. They are called integers. Integers can often be denoted by using capital Z. Integers include all the same numbers as whole numbers like 0, 1, 2, 3, 4, and so on. Except they also include all the negative of them as well, such as negative 1, negative 2, negative 3, negative 4, and so on. But again, integer do not include any decimal or fractions of numbers. The next classification numbers are called the rational numbers, which can be denoted by using the capital W. And again, rational numbers encompass all of the other classification that we have mentioned so far, as well as decimal and fraction. However, the decimal numbers must be the numbers that can be expressed as a fraction. So kindly refers to the situation, rational numbers which denoted by Q. So for this case, we only add on the decimal numbers and the fractions. So here we have the example for fraction or quotient, where we have P and Q. So P must be integer, same goes to the Q, and Q is not 0. For example, 17 over 3 is a fraction, kindly refers to the numerator where we have integer and the denominator also integer. So based on the situation, we can say it is a fraction and it is a rational numbers. Kindly refers to the decimal. We have to check whether the situation is repeating decimal. So for this case, 5.666 with the repeating 6, it is a repeating decimal. And we can say it is a rational numbers. Another characteristic that we can determine whether the situation is a rational number or not is refers to the terminating decimal. For example, we can write 5.6. So for this case, it is a terminating decimal. Because 5.6, then they stop for the decimal situation. So we can say 5.6 is a rational numbers. Another situation, is this situation a rational numbers? Kindly refers to the fraction where we have 19 over 70. Since it is a fraction and the numerator and denominator is an integer, so we can say it is a rational numbers. 19 over 17, which is equals to 1.117647, 0, and so on. So for this case, we can say 19 over 17 is equals to the decimal numbers, so it is still a rational numbers, even though they are not repeating decimal and not terminating decimal, because the situation is equal for both sides. So here we have the questions. Is these numbers a rational numbers? So in order to determine whether the situation is a rational numbers or not, we have to check the situation. Does the situation is a fraction? Does the situation is a decimal numbers? The answer is decimal numbers. Kindly check for the situation. Does the situation have repeating decimal? The answer is no. Does the situation have terminating decimal? So at here, the answer is no as well. Since the number does not fulfill both of the criteria, so we can say it is not a rational numbers. So bear in mind, what number is this if it is not a rational numbers? So here we have the situation. Given x is a number, then it is a natural numbers. Can we assume that x is also a rational numbers? Well, definitely the x also can be assumed as a whole numbers. You can ever assume that is also an integer, since it is an even a bigger set than the whole numbers. And finally, as we mentioned, you can also assume that it is a rational numbers, since rational numbers are the bigger set of the set of integer. And we can compare it to something like this. If I said that a person is in Kampa, can we also assume that this person is in Perak? Well, obviously, as well we would be correct to assume that this person is in Malaysia. Absolutely, since Kampa is in Perak and Perak is in Malaysia. Finally, would it be okay to assume that this person is on Earth? Well, of course. Earth is even bigger of a set of Malaysia. Now, there is a whole different set of number that is not within any of this. What I mean is natural, whole, integer, and rational. This set of numbers cannot be expressed as a fraction. Another way to describe this is that this set is completely separate from the rational numbers, altogether fittingly, so we can call this number of irrational numbers. An example of an irrational numbers would be the pi. And we know that pi is a never-ending numbers that does not repeat with a constant decimal or in a pattern of fashion. And this is what makes it irrational. Another example, the square root of 2 also turned out to be an irrational numbers since it cannot be expressed as a fraction. Lastly, the definition of the real number is the last classification that we will talk about, although there are some other classification that you might learn later on. So here we have the real numbers. Real numbers are simply all the rational and the irrational numbers combined. Kindly pay close attention to how certain number sets are literally in the other sense, but just remember that even though saying that a person is in Kampa must also in Perak. But in reverse, isn't it always correct? If this person is in Perak, it doesn't mean that they are in Kampa. Maybe they are in Ipoh or wherever else in Perak. Similarly, while we can say, for example, that all natural numbers are also integer, but we cannot say that all integers are natural numbers. The same applies to the rest of the layers of the classification that we have learned today. The classification of number might seem random, but they will be used over and over again, so it will be worth your time to learn it thoroughly right away. So here we are, and thanks for watching.